Hey guys, Miss C here. So today we are going to learn how to solve quadratics using the quadratic formula. This is the last method that we are going to learn how to solve quadratics with. And so, yeah, here we go. So this is the quadratic formula, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And so, guys, this is something that you will need to have memorized and you need to know. And so there are songs, there are little jingles that you can learn and Google on YouTube to memorize this, but this is something that you will need to know. But we're going to go ahead and get started. And so the first step I actually am going to write down as step 0. And so if you would on your notes page write the same thing here, is that the first thing that you need to make sure that you do before you start finding what A, B, and C are is to write the equation in standard form, because that is the only way to identify A, B, and C is if we have it written in standard form. So write equation in standard form is step 1 or 0, if you will, standard form. And just a reminder that that is ax squared plus bx plus c equals 0. So everything on one side of the equation. So now we can jump into step 1 of identifying what A, B, and C are, substituting them into the formula, and then simplify and write your solutions, okay? So this first one we have already has everything moved over to one side of the equation, which is super helpful. So we're going to go ahead and jump in, and I'm going to use different colors to show you guys A, B, and C. But really, guys, this is the easiest method to learn how to solve quadratics, just because it's just plugging in. So I see, I'm going to use green for A is equal to 1 because there is nothing outside of this squared term. And then I have this plus 9, so I see B is equal to 9. And then this last one here of C is, I'm going to change C to orange, and C is going to be negative 5, okay? And so now I'm just going to plug everything into the quadratic formula. And so I have x equals negative b, which I'm going to change to blue, negative 9 plus or minus the square root, and guys, please use parentheses, especially when you're dealing with these squared and all this multiplication. Using parentheses is so important. So square root of b squared minus 4 times 1 times c, which is negative 5. And all of this is over 2 times a, which is 1. Okay, so make sure, oops guys, I wrote b instead of 9, my bad. You're trying to go too fast. So now we have everything substituted into the formula. So now we can simplify, and I have x equals negative 9 plus or minus the square root of 9 squared is 81 minus, and again guys, this is why it's so important to use parentheses, because you're going to lose a negative somewhere along the way. So 4 times 1 times negative 5 is negative 20. And then all of this is over 2. So I can keep going and write x equals negative 9 plus or minus the square root of 81 plus 20. And then I have and I forgot my denominator. Over 2. You don't want to forget things as you work. You want to make sure to carry everything along. So I have x equals negative 9 plus or minus the square root of 101 all over 2. And guys, that is your final answer. When you would get to a point like this, you would want to see, can 101 be broken down into anything smaller to simplify that radical? But in this case, it cannot. Nothing that will come out of the radical. And so this is our final answer. And these are two solutions. That's exactly what this plus or minus means here, is that we have negative 9 plus 100 square root of 101 over 2, and then minus a square root of 101 over 2. So here's your solution, guys. use this problem as a guide to do number 2 on your own using the quadratic formula, and pause the video to do that, and I will go ahead and write the solution to number 2. So the solution to number 2 is x equals 11 plus or minus the square root of 109 all over 2. Okay, so now I'm going to go ahead and go to number 3. And so this problem, we don't have it set into standard form yet. So I'm going to go ahead and rewrite this. 3x squared minus 7x plus 16, because I moved that 16 over, equals 0. And now I can identify a, b, and c. So I have my terms here for a, b, and c. So I'm going to stay consistent where a is going to be green. So a is 3. B is equal to negative 7. And then C is equal to 16. Okay, and so now all I have to do is plug it into the quadratic formula. And so I have x equals negative 7 plus or minus the square root of negative 7 squared minus 4 times a is equal to 3 this time, and then our c value is 16. And this is another thing that's different about this problem, guys, is that our a value is bigger than 1, and so or just is not equal to 1. And so that's super important, because especially when we work with our denominator, where we have 2 times a, it's 2 times 3. You don't want to forget that there as well. And so, yeah, so now we're just simplifying. Everything is plugged in. If you choose to put this into your calculator, you are more than welcome to. If you have a calculator that keeps things in radical form, that is great, because that's exactly how you need your answers written. And so, but it is helpful to know you can plug in everything under the radical here into your calculator to find that value. And so negative 7 here is going to just be positive 7 plus or minus the square root of 49 minus 4 times 3 times 16 is going to be 192. Sorry for the wait there, guys. And then we have all of this over 6. Okay, so now I don't know about you guys, but I can start already seeing a problem here where my square root is going to give me a negative answer. So I'm going to end up with x equals 7 plus or minus the square root of negative 143 all over 6. Well, guys, we can't, taking the square root of a negative number is not going to give me a real solution. This is something that you'll talk when you get into Algebra 2, but you cannot take, there are no two numbers that multiply together to give you a negative value. And so whenever you end up with a negative under the square root, that means there is no solution to this quadratic. And graphically, if you're looking at this, all that means is that it doesn't cross the x-axis. So I don't know exactly what the graph of this function is, but it must be somewhere up here, and it doesn't touch the x-axis down here. So hope that's helpful, guys. You can go ahead and try number 4. I will go ahead and tell you that number 4 does have a solution, but you need to first move your c value over and do that. So pause the video, work on that one. Okay, and the answer to number 4 is x equals negative 5 plus or minus the square root of 57 all over 4. Okay, so if you need to work that one again, please feel free and use the notes from number 3 to do that, and come to class tomorrow if you still need help with that one. And then last one that we're going to do together in the notes, guys, is number 5. And so this one is special because the first thing that we see is that there is a GCF between all of these terms here. And so before we even deal with this problem, we want to go ahead and divide out this GCF. So I see a 2 in common everywhere. So I'm going to divide everything by 2, and I am left with x squared minus 7 equals 3. Well, I still need to get this into standard form, and so I'm going to go ahead and move this 3 over to the other side, and I get x squared minus 10 equals 0. And this one looks a little different because what are we missing here? I see a squared term and a constant, and so I see I have my 1 in front of x squared, and then I have my c term, but b in this case is 0. And so that's a big thing to notice here, guys. You can actually also solve this problem using square roots, but for the sake of practice with quadratic formula, we're going to go ahead and solve this with the quadratic formula, but I just wanted to let you guys know that it is possible to solve this using square roots. So we're going to go ahead and identify everything. So we have a is equal to 1, b is equal to 0, and c is equal to negative 10. Okay, so I'm going to go ahead and plug everything into the quadratic formula, and you please do as well. If you want to pause the video, try it yourself, and check yourself with my work. Please do, because you guys are going to need to be able to plug this in yourself. And so I have negative 0 plus or minus the square root of 0 squared minus 4 times 1 times negative 10. That is all under the square root, and all of this is over 2 times 1. Okay, so these zeros here, guys, is going to go away, right? Because 0 doesn't change the value in this situation because of the addition and subtraction that's separating it. And so we have x equals, I'm going to go ahead and get rid of 0, so we have plus or minus the square root. 0 squared, we have negative 4 times 1 times negative 10, which is 40, all over 2. So I'm going to go ahead and simplify my radical of 40. I have 4 and 10, 2 and 5, 2 and 2. I see a pair of 2's, and so if I rewrite this, this is a throwback to Unit 1. I see a pair of 2's, 1 comes out, 1 sacrifices, and so this simplifies to 2 square roots of 10. And so now I have an answer of x equals plus or minus 2 square roots of 10 over 2. Well, I can also simplify this fraction more because I have a common factor of 2 in my numerator and denominator. So the final answer to this would be x equals plus or minus the square root of 10. Okay, guys, so go ahead and try number 6 on your own. Here, pause the video, and I will go ahead and write the answer there. So the answer to number 6 is no solution. If you got to that point in this problem, you're like, wait, I have a negative under the radical, then you were doing it completely right. And so that is what's happening. And again, graphically, this looks like the graph is shifted up and it doesn't touch the x-axis. And so, great, guys. You can go ahead and, if you want more practice using the quadratic formula, there's a whole sheet in CTLS called 3.12 practice, and there's, I think, 12 problems on there for you to work through and to try using the quadratic formula.